Okay, welcome to level 2. Check your understanding, velocity, and acceleration definitions. All right, so our skill for this unit, 2.1, is I can define, differentiate between, and use equations for average velocity, initial velocity, final velocity, change in velocity, instantaneous velocity, and acceleration. So a lot of these you have seen before, some of them are new. And I call these the family of velocities. Because there's a lot of different ways to look at velocity. So average velocity we've seen before. It's the average velocity of an object is the total displacement divided by the total time of an object's movement. If an object has a constant velocity, then its average velocity is also its initial velocity, final velocity, and instantaneous velocity, right? So if an object has a constant velocity, its velocity is the same all the time. So its initial velocity, final velocity, and instantaneous velocity are all going to be the same. The symbol for average velocity is a V with a line over it, right? So you can see here, we have a V with a line over it, and it's change in x, so displacement over time. And we've used that equation before. Remember, change in x, displacement, or change in position, and the equation, change in x is equal to x final minus x initial. And again, that was from level 1, so you should all know that by now. Here's an example problem. Again, for a lot of these things, I say, hey, I want you guys to show me the equation. I want you to show me the working. And I want you to show me the correct answer with units. Okay, so here I've got, if you drove 10,000 meters from school to the Roman amphitheater at the city center and it took 1,000 seconds, what is your average velocity in meters per second? Well, my average velocity is going to be my change in x over t, so my displacement over time. That's 10,000 meters over 1,000 seconds, 10 meters per second. Easy. And look, I showed my equation. I showed my working, which is this section right here. And I showed my correct answer with units. These are the units right there. Okay. In the question above, were you always going 10 meters a second? No, of course not, right? There's stop signs. You have that turn onto Zacharan Street that takes forever. Then you speed up to go by somebody. Your speed is changing the whole time. But 10 meters per second was our average. The average velocity can also be found just like taking the average of any two numbers. And what I mean by that is if I said, oh, I have 10 marbles on day 1 and I have 20 marbles on day 2, what's the average number of marbles I had? Well, I would just go 10 plus 20 divided by 2 to get 30 divided by 2, which gives me 15 marbles, right? If I'm just getting the average of two numbers. So we can do the same thing with two velocities. What is the average velocity of an object that starts at rest and accelerates to a velocity of 6 meters per second? Okay, so if we're accelerating, we weren't always going 6 meters per second. That's my final velocity. So my final velocity is 6 meters per second. My initial velocity was 0. So the average velocity that I was going is going to be 6 plus 0, which is equal to, divided by 2, which is 3 meters per second, right? Because I wasn't always going 6 meters per second. I started at 0, and I sped up until I got to 6 meters per second. Okay? And what was I going on average? On average, it was 3 meters per second. Initial velocity is just the velocity that you start with. So it's not always 0. Sometimes we can have a velocity, like maybe a car, if we're looking at a graph of a car's velocity versus time, maybe it's slowing down. Okay, so here the initial velocity might be 5 meters per second and its final velocity is 0. So the initial velocity isn't always 0. Just keep that in mind. For most of the stuff that we do, it is 0, but it's not always 0. The final velocity is just the last velocity that we're looking at in the object's motion. So if an object accelerates from 2 meters a second to 6 meters per second over 2 seconds, its final velocity is 6 meters per second. Now we could figure out the acceleration, which is a change in velocity over time, by looking at my change in velocity was 6 meters per second. Finally, right, it's VF minus VI over time. So that would be 6 minus 2 divided by 2, which becomes 4 divided by 2. So I get 2 meters per second squared would be an example of the acceleration in that situation. A change in velocity, just like we had change in position, is just the change in velocity is v final minus v initial. A change in velocity is used in the equation for acceleration. So we can see a change in velocity, pretty easy. Just going to that. Oh my goodness, is that a typo? Yes, it is. Oh man, that should be 32 meters per second. I'll need to change that when I go back in. Mental note to self. Okay, notice the above equation, the change in velocity is positive, okay, because we're speeding up. We're going from 8 meters per second to 40 meters per second, so my acceleration is positive. Now let's look at a different example. Here, what is the change in velocity of an object that accelerates or decelerates from 20 meters per second to 4 meters per second? Well, my velocity final was 4, my velocity initial was 20, so that gives me a negative 16 meters per second. That means I'm slowing down. Now that also depends on the direction of the car, but you won't get into that until AP Physics. Instantaneous velocity is just how fast you're going at an instant, right? If you're driving in a car, it's what the speedometer says. So if you have a speedometer on your car, it tells you how fast you're going. Right? The speedometer tells you your instantaneous velocity. Level 1, acceleration. So you've done this before. You guys have done acceleration equals change in velocity over time. 8 meters per second divided by 4 is 2 meters per second squared. Again, we have the squared in acceleration. So you guys have actually done all that. You've actually done these questions before as well. So let's do this one again, just in case you want to see it. If a car has a velocity of 4 meters per second and accelerates to 20 meters per second in 10 seconds, what's the car's acceleration? Well, we did that before. We said the initial was, change in velocity. So velocity final minus velocity initial over time. Velocity final is 20 minus 4 divided by 10. That's equal to 16 divided by 10, which is 1.6 meters per second squared for this first question here. Acceleration is a vector. Then what does a negative sign mean for acceleration? Well, it means it's slowing down. And that again was from 1.1. Now, here comes level 2 acceleration. It's the same idea, but we're looking at things accelerating because of gravity. And gravity we call g, or little g. And we're also using change in y. So we've been using change in x for things going this way and that way. Now we're going to use change in y for objects going up and down. Okay, little g is the acceleration due to gravity. On Earth, the accepted value for g is 9.8 meters per second squared. Notice the units are in meters per second squared, so it's an acceleration. When we do experiments or challenges in class, we'll use g equals 9.8 meters per second squared, as it will make our predictions more accurate. However, when we are doing practice problems in class, we will round little g and use 10 meters per second squared. And again, this is like if you drop a pen, if you drop a ball, this is how fast the ball or pen is accelerating. It's at 10 meters per second square. In free fall, up will usually be the positive direction, therefore little g often comes with a negative sign. So you might see it as negative 9.8 meters per second squared. Change in y is vertical displacement or vertical change in position. So just like we have our change in position in x, we have a change in position in y. It's just y final minus y initial. And now here comes your new equations. They might be difficult at first, but just like the other ones, you'll get used to them. So here I can tell you the time that it takes for an object to get to the ground if I know how high the object is being dropped from. Right? So if I have a cliff and the change in y is this far, and I know g on Earth, I can give you the time that it takes. So here's an example. A metal marble is dropped from 5 meters high. Determine the time it takes for the ball to hit the ground. Note, in this case, little g is in the negative direction. So my change in y is going to be negative 5 because it's initial minus 5, change in y is equal to y final minus y initial. So that's where this came from. The 2 is there already, and then I have g. Remember, it's just a calculation, so I don't need to use 9.8. And I get 1 second because it's 2 times 10 is 10 divided by 10, which is equal to 1. And I take the square root of those, and I get 1 second as the time. So we can do it this way. Now, actually, the same equation, but rearranged, I can solve for the vertical displacement if I have a time. So let's check the example below. If I put in 5 seconds here as my time and say it took an object, let's say I threw an object off a cliff and I timed it and it took 5 seconds to hit the ground. Well, there's my 5 seconds there. I square that, multiply it by 10 for gravity, and then divide that by 2, and I get 125 meters. So again, if I have 5 seconds, it would just be gt squared over 2. So that's going to be equal to 10 times 5 squared over 2. That becomes 10 times 25 over 2. And that becomes 250 divided by 2, which is equal to 125 meters. So again, equation. Working, correct answer with units. Finally, be cognizant that these equations can be applied to objects accelerating in the horizontal direction as well. All you have to do is switch change in y with change in x and switch little g with the acceleration of the object in the horizontal direction. So that's saying if I have a car that's accelerating and I know that the car has an acceleration, it's a Tesla truck, obviously, and I know it can accelerate at 15 meters per second squared. That's fast. Then I can use that and I can say, okay, well, if I time it, let's say I time it for, let's add something weird. Let's say I time it for 8 seconds. Then how far will it go? Notice I've put down like what I know. My acceleration is that. So the equation I'm going to use, like we said, all I have to do is switch these out a little bit. I'm solving for change in x. So that's going to be equal to, instead of g, it's a, because that's the acceleration. T is the same, and it's divided by 2. So my change in position of this car is going to be 15 times 8 squared divided by 2. That change in x then is equal to 15 times 64 divided by 2. And that whole answer, if I pop that into my calculator, becomes 15 times 64 divided by 2, 480. And it's a change in x, so that is meters. Again, I have my equation. I have my working, which is all of this, and then I have my correct answer with units. Okay, that's the main part of the chapter that we're going to be going through. I highly recommend practicing these questions a lot. They're new for you guys, and making sure you know how to do the square root on your calculator. Make sure you're doing the order correctly. Make sure you know how to do the square on your calculator. Make sure you know how to do the square correctly. And I look forward to seeing your learning. Let me know if you have any questions. Thank you.